Okay, I'm going to redo an explanation of number 5. So you've got New Mexico over here, and it's 1,000 miles from Memphis. So that's 1,000 miles. So what we're having you do is aim the plane up here. I'm going to call this X and not theta. We're going to leave this as theta, and I'll explain more about that later. And then the wind came from the north and went straight down. So that's the general picture that I'm working with. So my first equation that I'm going to do on A is your plane, which you're going to do, which my plane's going to go in this direction. I'm going to call this theta, and I'm going 250 miles per hour. So for my plane, my equations are going to be x equals 250 cosine theta t. Because I don't know what theta is yet. Hold on, let me do some pointers. So I don't know what theta is yet. Ooh, that's the wrong pointer. I don't know what theta is yet. Oh, geez. Okay, it's a better pointer. I don't know what theta is yet, so I'm going to leave it blank in here. And my y equals 250 sine theta. So when I want the plane's part of components, or the plane's contribution to the situation, this is the plane. Okay, so I'm going to go on the next. Part B has me do the wind. Okay, so my wind, they said, was going in this direction. So I need to know what this is, and that's 270. Go back to 3. Okay. So then my equations for my wind are, oh, yeah, so 270. So I'm going 20 miles per hour, because I'm going 20 miles per hour for the wind directly south. So 20 cosine 270 and 20 sine 270 for my wind. And if I stick cosine of 270, if you remember, this is 0, -1. So my x equals 20 times cosine at 270 is 0. Sine at 270 is -1. That gives me 0t and -20t for my wind. So these are my wind contribution components. Okay. Okay, so now I'm going to kind of go in reverse order. I'm going to do D and E in reverse order. I'm going to do E first. So when it says write equations to simulate your path, that basically means find the resultant. And your resultant in this case, if you look back at your initial picture, you want to end up here. So you took your plane up here, the wind pushed you down, and this is your resultant. And if you remember, I want to end up, there's 1,000 miles between Memphis and Albuquerque. So if I picture this as 0, 0, my resultant is -1,000, 0. So I'm 1,000 left, 0. So my resultant equals my plane plus my wind. And so my x value is -1,000, my y value is 0. That's for my resultant. My plane was 250 cosine theta, 250 sine theta t on both of them. And my wind was 0t and -20t. So all I'm doing right now is combining my resultant, my plane, and my wind. My plane plus my wind equals my resultant. And I'm going to put all of these together in order to find out what this angle is here. This angle theta, oops. I want to find my theta here. I'll call this x for now, but I want to find out what theta is. So I'll do that on the next screen. So now I'm going to kind of go back and go do D. I'm going to do this differently. So I'm going to determine theta. Okay. So I'm going to use the y part of the equations in E. So you had negative 1,000, and here's why you use those. Cosine theta t. And you had plus 0t, but you don't need that. 250 sine theta t minus 20t. If I use this equation to solve for t, because obviously there's no plus 0t here, I could divide by 250. But if I divide by 250, I'm going to get negative 4 equals cosine of theta. And if I do cosine to the negative 1 of negative 4, I won't be able to find t. It'll tell me error. So you're going to have to use, oh, that's a really bad, hold on. Okay, that's supposed to say use. I'm trying to figure out how to, oh, there's the eraser. Okay. I'm going to erase this because that was a really bad use. Let's try and write this again. Okay. So I'm going to use my y part of my equation. That's this to solve for theta. And remember, theta is this. So I have 0 equals 250 sine t minus 20t. That's 20t equals 250 sine t. So I can divide both sides by t and get rid of that. Move over my 250 here, and I'll get 20 over 250 equals sine, oops, I forgot the theta. So when I stick in sine to the negative 1 of 20 over 250 in the calculator, you're going to get two answers. And remember, when you did arc functions, if I do second sine, I'm going to get 4.59 degrees, but that's for this first quadrant. If I want the 4.59 in here, which is the one that I want, I don't want the 4.59 over here, but you will need the 4.59 for this angle. So if this was 4.59 in here, then this one's 180, hold on, 180 minus 4.59, you're going to get 175.41 degrees. So my theta here is 175.41 degrees. I'll need the 4.59 part a little bit later, so I'll use that again. And so that's finding my angle that the plane is going to go from 0. We'll worry about the heading and the bearing part later. But that's basically just finding your theta for that part. Okay, now for E, I'm going to write the equations now to represent the resultant now that I know that theta is 175. So my equations are x equals 250 cosine. Now I can put in the 175.41 degrees plus my 0t, which I don't really need, but 250 sine 175.41 t minus 20t. And so when I stick this in the calculator, I'm going to get negative 249, oops, that's a 2.20t, because this really doesn't matter. Then when I stick this in the calculator, I get 20t minus 20t, which if I did it correctly, I should get 0. Because you remember you went 1,000 this way. So that vector over here should be negative 1,000, 0. So I end up with x equals negative 249.20 t, y equals 0 t. Those are my resultant vectors. Okay, what this is going to tell you is that this basically is just a modification of your distance equals rate times time formula. And I'll go over that on the next screen. I just don't have enough here. Okay, on the last screen, we got that our vectors were 249.20 t and y equals 0 t. Okay, this is my resultant. So this here is just a modification of distance equals rate times time. 249.20 t. So here's my t. X is my distance, R is my rate. So your plane ends up going 249.20 miles per hour as a result of your wind. So because that wind pushed you down, it changed your speed. So if I ask you how fast you were going as a result of the wind, that's how fast you're going. Okay, the last part of my problem asks, oops, not E. It's supposed to be F. Ask you for the bearing of the plane. Well, bearing. Remember that we did that your thing was going here. This is 4.59. My bearing, remember, goes from north clockwise to this. So 270 plus 4.59 is going to give me, the plane is actually going at a bearing of 274.59 degrees at 249.20 miles per hour. That's the direction that you have to head to that. So in order to get there, that's the speed that you have to do that at.